The mean, or average, of observations is the ratio of sum of values of all the observations divided by the total number of observations. Let x1, x2, xn be observations with respective frequencies f1, f2, fn. This means that observation x1 occurs f1 times, x2 occurs f2 times, and so on. Now, the sum of the values of all the observations equals f1 x1 plus f2 x2 plus fn xn, and the number of observations equals f1 plus f2 plus fn. So, the mean x bar of the data is given by x bar equals f1 x1 plus f2 x2 plus fn xn divided by f1 plus f2 plus fn. We can write this in short, using the Greek letter, read as sigma, which means summation. X bar equals sigma fi xi divided by sigma fi. Example. The marks obtained in mathematics by 30 students of class 10 of a certain school are given in table the below. Find the mean of the marks obtained by the students. Marks obtained xi, number of student fi. Let us reorganize this data and find the sum of all observations. Sigma fi equals 30. Sigma fi xi equals 1779. Place these values in the x bar formula. X bar equals sigma fi xi divided by sigma fi equals 1779 divided by 30 equals 59.3. Therefore, the mean marks are 59.3. In most of our real-life situations, data is usually so large that to make a meaningful study, it needs to be condensed as a grouped data. So, we need to convert ungrouped data into grouped data and derive some method to find its mean. Remember that while allocating frequencies to each class interval, students whose score is equal to in any upper class boundary would be considered in the next class. For example, 4 students who have obtained 40 marks would be considered in the class interval 40 to 55 and not in 25 to 40. Let us form a grouped frequency distribution table. Class interval 10 to 25, 25 to 40, 40 to 55, 55 to 70, 70 to 85, 85 to 100. Now, for each class interval, we require a point which would serve as the representative of the whole class. It is assumed that the frequency of each class interval is centered around its midpoint. So, the midpoint of each class can be chosen to represent the observations falling in that class and is called the class mark. Recall that we find the class mark by finding the average of the upper and lower limit of the class. Class mark equals upper class limit plus lower class limit divided by 2. For the class 10-25, the class mark is 10 plus 25 divided by 2 equals 17.5. Similarly, we can find the class marks of the remaining class intervals. We put them in the table. These class marks serve as our xi's. We can now proceed to compute the mean in the same manner. Sigma fi equals 30. Sigma fi xi equals 1860. Place these values in the x bar formula. So, the mean x of the given data is given by x bar equals sigma fi xi divided by sigma fi equals 1860 divided by 30 equals 62.